What do you mean I don't have a skeleton? How do I survive? I don't know, man. You just do. Good morning, everyone. Welcome to Aquarium Online Academy. My name's James. I'm from the Aquarium Education Department. We're going to talk about all of these lovely animals behind me here, but they have a very special thing in common that we're going to make sure that we talk about together. And if you want to ask me questions about all these cool things, you can. My friend Ty is behind the scenes controlling the camera, so he's going to put up our text line. If you want to text us questions, Mr. James, how to blah, 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 you can. Text us at 562-286-1838, and you can ask about all these cool things in there. Even if it's, what's that? I can help answer that for you. If you have a big question, or maybe you're not watching live at 9 a.m. on Wednesday, you can email us at live@lbaop.org. Well, let's get started talking about all these cool animals. But not just these, even my friends I started out with. They belong to a very specific group called the invertebrates. Have you heard that word before? Let's put the word up on the screen because it's kind of a big word to spell. Invertebrate. Well, what is that? That means they don't have vertebra or a backbone. Do you have bones in your body? Where are the bones in your body? You almost can't point and not find one because we have bones all over the insides of our body. Lots of them are in our hands. We have some really big hard ones in our heads and our arms and our legs. So we have a skeleton on the inside, but specifically we have our spine or our backbone. All of these animals on the screen don't have a spine, and most don't have anything even related to a skeleton. There's a few animals that kind of have a different skeleton than we do, but we'll talk about how they are or are not an invertebrate. So let's take a look at some of these animals. Let's take the word away and let's just observe who's in the water. Who can you find? What do you notice happening inside this video? I notice there's a lot of color. What do you notice happening? Even what colors do you notice? Because there's a lot here. This is a model of a tide pool, a shallow exhibit or a shallow habitat along the coastline. And it happens all over our west coast and our east coast in North America, all over every coastline, but this one is specific to our California coast, especially Northern California. The water's pretty cold, and it's kind of dark sometimes. That doesn't mean there isn't a lot of colorful animals. There's a lot of colorful animals in here, aren't there? I got everything from pink and blue, yellow, red, orange. I got the whole rainbow in this one exhibit. So there's a lot of colors. It's not just tropical reefs that have a lot of color. Even our kelp forest and tide pools along our west coast have a lot of color. So who did you recognize in the water? We have sea stars. There's our sea star. We have some littler stars, the bat stars. We have anemones. Everybody show me your anemone tentacles. Anemone. We have snails right here, kind of where I was standing. We have this little lump right here. That one's not hard to see. We'll talk about that one a little bit later because it's related to stars, but it's different. We also have down here urchins, sea urchins. Have you heard of all of these animals before? We'll explore a few of them, but keep in mind they all belong to that group, the invertebrates, meaning no backbone, no spine. Well, what about some other animals that kind of look like they have hard parts? What about crabs? Let's take a look at a crab, Ty. Oh, that's so cool. Does this look squishy like the other animals are? If we had a crab out here that we could touch, I don't. But if we did, do you think it'd be really squishy? Probably not. What do you notice about their shell? They do have what we call a shell, but this is a special shell. It's not like a clam. This shell is a skeleton on the outside. Is our skeleton on the outside? Not supposed to be. It's actually bad if it is. Our skeleton stays inside. So we're squishy on the outside, and our skeletons are inside. That makes us a vertebrate because we have that spine, we have that backbone. Their skeleton is on the outside and very different from ours. So even though they might have an outside skeleton called an exoskeleton, they're still an invertebrate because they don't have a backbone. Our little crab model here, no spine or backbone. Even though they have a hard shell, they don't have that skeleton that we consider a vertebrate like us to have. So keep in mind that just because something on the animal might be hard doesn't mean it's not an invertebrate. It could still be an invertebrate. Depends on if it has that spine. Now, what else do you notice happening with this crab? Where are the eyes of the crab? Way up here. Their eyes come off the top of their head. Some crabs are on just the top of their shell, but other crabs, or their cousins, the lobsters, their eyes stick way up off the top of their body. So their bodies are a little bit different than some of the other invertebrates. They have legs, they have eyes, they have mouth parts that are great at tearing their food apart. But what about a really squishy invertebrate like an anemone? Do you think they have the same body parts? Let's find out. So, whether you guessed yes or no, let's see. All right, can you find the claws, the eyes, the mouth of the anemone? Do you see any of those things on here? Well, these aren't claws, but what are these? Tentacles. The tentacles kind of do a similar job to claws. Instead of grabbing and tearing, they do grab. So claws and tentacles are good at grabbing their food. So different invertebrates have different body parts that have the same job, but this anemone has no hardness to it at all. It's very squishy. In fact, you have the opportunity to touch an anemone here at the Aquarium of the Pacific. We have a special touch lab where you can come up and you can touch the tentacles or you can touch the sides. But there is one space we can't touch, and that's their mouth. So they do have a mouth. Did you find it? It's this belly button looking thing right here. That is not their belly button. That is their mouth. Without teeth, without hard parts to their body, how do you think they eat? If a crab has claws or has little tearing mouth parts, they can take bites, or they can at least take their food into smaller pieces. What about an anemone? Do they chew up their food? What do you think? Not quite. An anemone is kind of like what we do when we're little, like toddlers, and we don't know how to do the eating things. We just shove the whole thing in our mouth. We don't know that we have to chew it in order for it to work correctly for our bodies. They will swallow everything they need to eat whole. And if they can't digest anything, they spit it back out. There's one way in and one way out. Kind of gross and kind of cool. Science is really gross and cool at the same time. Their bodies are simple enough that they don't have a digestive system like our bodies do. So our bodies is entirely a one-way system, one-way street. If we're sick, then it goes the wrong way. But for anemones, it always goes both directions. They eat their food in the one opening, and they just kind of hold it in their stomach that they have, and then they spit everything out that they can't digest. So their bodies are much simpler and much different than a crab. A crab has a full digestive system just like we do. So their bodies are closer to ours in terms of like what certain things look like. But their bodies are still very different from ours. Now, anemones belong to the same group as jellies and corals because of these tentacles. These tentacles sting and grab their food. Crabs have claws to tear, or grabbing parts to tear their food up. All of the anemones, jellies, and corals have tentacles to grab their food. Well, other animals have tentacles, don't they? Like my octopus friend we started with, or their cousin, the squid. Their bodies are even more interesting. Let's take a look at a picture of an octopus. Now, an octopus like this one, this is a giant Pacific octopus. This is actually relative size. If I was in front of the octopus window, And this one is Godzilla. If Godzilla were out, Godzilla passed away. We don't have Godzilla. They don't live very long, unfortunately. So that's another thing we can talk about is their bodies just don't live very long. Godzilla would be this big. Anemones, interestingly, can live 100 years or so. But this really cool octopus has a short lifespan. So even though their bodies are more complex, they have eyes, they have mouths, they have tentacles, they have body systems, a whole lot of stuff on the inside like we do. They don't live very long. That's normal for them. That's okay. That's how their bodies are supposed to be. But these suction cup things, we call them tentacles generally, but we've been saying it wrong the whole time. Now, it's not that we're mispronouncing the word tentacle. We've been calling these parts the wrong part for a long time. And we understand what you mean when you say octopus tentacles. I'm not going to correct you. But the science word for these are actually arms. What? Yes, they have arms, they have eyes, they have a mouth, they have a whole digestive system. And their cousin, the squid, has arms and tentacles. That's kind of the interesting thing. These longer ones, these are the tentacles. The tentacles only have suction cups down here at the end. Arms have suction cups all along the length of it. But their arms and tentacles are not the same as anemones, are they? Do they sting their prey with their tentacles and arms? What do you think? Not quite. Now, an octopus, cool thing, does have venom. But it's not in their suction cups, in their mouth. They can sting you with their bite, kind of like a snake would. So they have venom to help capture their prey because they need that. Their arms and tentacles are super strong and can hold on to prey really well, but they need that extra venom in their bite to help capture their prey. Sometimes their prey is a little wily, and none of them really want to be prey, but one of their prey's defenses might be to be strong enough to get away. But if they can bite them with their venom, that stops that, and the prey actually will be eaten, but that's because it gets to eat. So some of these animals have really interesting abilities to survive their habitats. Even though they have no skeleton to hold themselves up with, they have some pretty cool adaptations to do all the other things that they can do. They don't need a skeleton. That's even better, is that they don't need these hard parts to do all these other cool things. Well, let's go back to the tide pool and take a look at some other animals in there. So we talked about anemone tentacles and how they eat. We talked about crabs. There's no crabs you can really see in here. We talked about crabs and how they eat. Kind of talked about the octopus and the squid. Don't forget, ask us questions if you want to. We have our text number down here. Text us questions. Ty's ready with his marker to hold up a sign with your questions for me. Now, what is another animal that we could talk about in here? Oh. What's that, Ty? Oh, he wants to talk about sea stars. They're Ty's favorite. They are cool, though, but they're not as cool as an octopus. Actually, they are pretty cool. Sea stars, or what you often call a starfish, again, that's a word that we use to describe a thing that in science we're like, that's not the right word, but I'm not going to correct you. The sea stars, they have very special abilities as well. Now, by looking at them, let's make some more guesses. Let's guess. Do you think this sea star is going to be really squishy? Pokey? Hard like a rock? What do you think? What about this sea star over here? Do you think that one's going to be squishy, pokey, or hard? What about that one? Now, if you've had a chance to visit us and check out our tide pool that you can touch them in, you already know the answer. They're kind of all of the above. They're squishy, they're pokey, they are hard. It depends on the kind of sea star you're looking at. The ochre stars and the giant spine stars, they are pokey. They have what are called bony plates in their skin. Could you imagine having bone in your skin, like it's part of your skin, and that's your armor? Oh, they're armored against predators. Would you want to eat a sea star? Do you think they look that tasty? I mean, I don't know if I think a lot of things in the ocean look tasty, but they are. Who do you think would want to eat a sea star? It might surprise you. Sea otters will eat sea stars. Yeah, sea otters are very good at picking things up off the ground, even a sea star, which can hold onto the floor very well. Otters eat a whole lot of things. Otters will eat almost anything in this exhibit. They usually don't eat anemones, but it's not that they can't. They probably could if they wanted to. I don't know if they want to, though. But sea stars have armored skin to prevent things from poking and grabbing at them. They have really strong feet to hold down on the floor so you can't pull them up. But otters are pretty good at pulling them up. Now, if this was an area right next to the water line, where at a low tide, it would be exposed to the air, there are suddenly new predators. Instead of water predators, like an otter or a fish, when it gets exposed to the air at a low tide, now birds can come out and get them, coyotes. A lot of wild animals will come down to the shoreline during a low tide to hunt and grab food. So sea stars have a rough life, but they are very well adapted to their environment. They can survive a lot of different things. Extra heat and sunshine from being at the coastline, sea otters from picking them up, birds from picking them up. Their bodies are often in this star shape. That's how they get their name. But sometimes sea stars are in some very different designs, like the sunflower star. Is that what you would expect a sea star to look like? Ooh. Now this is one of the biggest sea stars on the planet. I think actually they are the largest species, if you can find them that big. It takes a while for them to get this big. So this is also accurate size. If I was standing in front of their window next to a sunflower star, they can get 3 feet wide. This is actually life size for a sunflower star. That's pretty cool. Now, the other cool thing to look at, we're looking at the underside of the sea star. What are all these hairy things down here? Do sea stars have fur? Ty's laughing at me. What? It looks like fur, doesn't it? Kind of. These are feet. Yeah, these are sea star feet. Let's see if we can find a close-up of some sea star feet so we can look at what they do. The crab crawls around. The octopus can swim and kind of walk around. But sea stars, how do they move? They have these little tube feet. They're kind of like little straws with glue on the end that they suction and stick down onto things. And that's how they move. Do you think you could win a race with a sea star? Probably. You want to see how fast they really move? My sea star impression. And go! This is very exhausting as a sea star. This is so fast. Sea stars don't move very fast. If they don't move fast and they take a long time to walk, they have all these little weird feet on the bottom. What do they eat? So if you swim fast, you probably catch fast food. If you have to sit there and just sit still like an anemone, you grab whatever comes near you. What if you walk slowly? What are you going to eat? Ooh. Sea stars' favorite foods tend to be things with shells like mussels, clams, maybe. In fact, a sea star will eat just about anything on the ground because they don't have to take bites of it. They don't have to, it doesn't have to be tiny for them to be like, and shove it all in their mouth. They do something very different from all the other animals on our list today. Do you know how a sea star eats? Kind of gross. I don't recommend you try it at home. Ever. They will spit out their stomach, their body. They flip it inside out and wrap it around their food. And they start to digest it outside their body. So it's gooey. And then they suck everything back in. Seems kind of strange. But keep in mind that there's a lot of animals that do that to their food. They just don't spit their stomach out. Spiders, when they bite their prey, the venom that goes into the prey makes it a little gooey. Spiders don't have teeth. They can't chew and chomp on their food. They don't have tearing hands like a crab. They can't take apart their food that way. So their venom helps liquefy the food. Well, the digestive enzymes a sea star has helps liquefy their food or make it gooey, so they can swallow it all in one shot. Sea stars are pretty interesting in that way. One of the few animals that digests their food on the outside and then sucks it all in by flipping out their stomach. Kind of an interesting way to do it. Here's actually a picture of it. Looks very goopy right there. We'll give them pieces of fish. I think this actually is like a piece of sardine. Like the silvery colors right here. It's probably scales. So we'll give them a piece of fish. They'll crawl on top of it. They have on top of their food in order to grab it and eat it. So if I have my sea star model here and it's walking along the floor, it has to be on top of the food to start eating and digesting it. Well, how do you know? How does a sea star know it is food? Why don't they just start spitting their stomach onto everything? It's actually their feet. So look at these big old feet on this leather star. I know this is a chocolate chip star, I think. Their feet also taste everything. Tasty. So they can taste their prey with their feet. They kind of touch it, test it, and if it tastes like their food that they could eat, they'll start spitting out their stomach and digesting it. Cool thing about the octopus and squid, their suction cups do the same job. These are very different animals, but the little parts on the bottoms of their body both do the same thing. Instead of an octopus trying to take a bite of everything and be like, oh, that's not food. Oh, why did I do that? Their tentacles and arms can do that for them. So an octopus arm has like 200, 250 or more suction cups per arm. And each one of those can taste their food. So if an octopus is like, that could be food, they can stretch that arm way over, test it, and then go attack that thing to get their prey. Because usually things don't want to be eaten, so they have to actually work to go get their food. Well, a sea star doesn't have to use as much energy because their food is also sitting on the floor, not moving, much like they will. But then sea stars can also become scavengers. Have you heard the word scavenger before? It means they'll eat whatever's lying around. It could be alive or not alive, and they'll eat it. And we need stuff like that in nature. We need animals that scavenge because they clean up the leftovers that others have left behind. Now, a really good cleaning up animal, mentioned them earlier, we're going to come back to it, it's the sea cucumber. Sea cucumbers are cousins to sea stars. Let's take a look at a sea cucumber. Looks just like a sea star. No. But here's the cool thing. So the inside of their body has parts that look like a sea star. So if you imagine a sea star, like our fingers, a sea star, if you squish your hand down, you have your 5 fingers when you hold it up like this, right? And your fingers are kind of like in a tube. That's a cucumber. So that 5-point idea, those 5 arms, you stretch them out like this, it's kind of like having a tube. They have similar insides to the way a sea star works. Their bodies are a little different. They do have a head and a tail end, and they do have a complete digestive system. So they have a mouth, stomach and intestines, and a back end. And they do a lot of cleaning. They clean up after a lot of animals. They have all these fun little tentacles come off of their face, and then they just stick their face on things, start sucking up their food. Here's another sea star, or another sea cucumber. Here you can see all the little mouth parts sticking out where they're cleaning up the rocks. Now, they might eat some of the algae, but usually they're going to eat most of the leftover animal stuff. Now, this could be like leftover food. So sometimes when we feed our animals in the touch lab, leftovers like crumbs come off. They'll clean up crumbs. But the other kind of gross thing they do is they eat the waste of everybody else too. They're like the vacuum cleaners of the ocean. They just don't move very fast to do that. But they do clean up after everybody else. They have pretty interesting looking bodies. Now, we said sea stars can be squishy, pokey, hard. What do you think this one's going to be like? If you got to touch a sea cucumber, what do you think it would be? I mean, we can see kind of these like pokey looking parts on their body. Do you think they're kind of sharp and pokey? Or do you think they're not? They are pokey, right? Sea cucumbers pretend to be pokey. Their bodies are all squish. So these things that might even look like spines are not even really that hard. But they do help them sense their environment. Just like you can feel the wind blowing through your hair, they can feel water moving around all these little projections on their body. So it helps them explore their environment around them. And then these fun little fan-shaped mouth parts help suck up their food, which could be anything lying around, anything left over. That's pretty cool. Now, are there other invertebrates that you want to talk about? Well, if you don't tell me, I'm going to make Ty pick a random one. And Ty's going to have to surprise me with it, and we can figure out some cool things about this animal together. A ghost? No, it's not a ghost. What is this animal? It's a jelly! So, in science, we call them sea jellies. If you call them a jellyfish, I know what you... Don't worry. The science word is sea jelly. Are they a fish? No. They don't have gills. They don't have mouths with the mouths that a fish have. They do have a mouth, but it's kind of just like an opening that the food gets thrown into. They don't have scales. They don't have fins. So they're really not a fish. Their bodies are really cool, but their bodies are simpler than a lot of the other animals. The octopus has gills on the inside of its body to breathe with. The sea star actually breathes through its feet. Same with the sea cucumber. The anemone and the jelly are related. So they can't breathe out of their feet. They don't have feet. They don't breathe out of their mouth. They don't really have a mouth that does that. They breathe out of their skin. Interesting. What else do you know about jellies? What have you heard about jellies? Ah, they sting. Yeah, they do. So remember, jellies, corals, anemones all sting their prey with tentacles. But there's a couple different tentacle-looking things on here. Which one is the tentacles? Do you think it's the fluffy ones, or do you think it's the long, skinny ones? It's these long, skinny ones. Now, this looks like, I think this is a Pacific sea nettle. They have really long, skinny tentacles. The bigger the tentacle, like the longer it is, the bigger the food they can capture. These fluffy-looking ones in the middle aren't just to look pretty. This helps them eat their food. So the big, long tentacles grab their food, it gets stuck to them, and they get stung and captured. And then these feeding arms, or feeding tentacles, grab the food off of the stinging ones and slowly move it up to their mouth. Remember, their mouth is not like teeth. There's no tearing parts. It's just an opening that the food gets thrown into, and then they start to digest their food. Well, how do jellies swim? Do anemones swim? Not really. There's one that does. It's kind of funny. These do swim, but not very well. Kind of like when we're learning to swim for the first time. Maybe we have some floaties on. We're not really good at doing anything. We just kind of bob and move around and sink a little bit. We're not supposed to. We get picked up. We don't swim very well when we're first learning how, because our bodies just aren't taught how to do that yet. But eventually we can swim much better. They never really get very good at swimming. Their swimming ability is just bloop, bloop. And if the water started pushing against them, they get pushed with the water. Wherever the water goes, their bodies get pushed. So they can kind of swim around a little bit, like, ooh, what's over here? Oh, the water's pushing me away. They can respond to light. They have something called eye spots. So our eyes can see lots of things, objects, sometimes different colors. But if we close our eyes, we only really see shadows, bright and dark. That's about all a jelly can see, bright and dark. They can't see stuff, and even if they could, they don't have a brain to figure it out. They don't need a brain to survive, just like most of these animals we talked about today don't need any other hard parts. The only hard part this animal needs is its chewing mouth. The only hard part an anemone needs is nothing. They don't need any hard parts. They don't need any hard parts either. They don't live a very long time, but they reproduce in large volumes. Kind of the same with a lot of animals. If they have a lot of babies, they don't really live too long sometimes, especially with the invertebrates, the animals without backbones. It's a little bit different for animals with backbones. Well, that's about all the time we have to talk about invertebrates. We're going to have our 10 o'clock Spanish language program. So if you want to tune in during the next hour, you can tune in for our Spanish language program. We also have more programming coming up next week, Monday, Wednesday, and Thursday, I believe. So tune in for more of our Aquarium Online Academy, Monday, Wednesday, and Thursday. And if you have questions that didn't get answered today, email us at live@lbaop.org. Have a good rest of your Wednesday, everyone.